Hello everybody, welcome back to From Rhythm to Algorithm, part I'm Not Sure. Today we'll be picking up where we left off. Last episode we covered was called the split path paradox, or we resolved the split path, what presented as a paradox, then just discussed how you can have what's called measurably irrelevant states, just quantities that exist or properties of a system that exist that are true, they're real, but you can't measure them and you don't know them, but they're measurably irrelevant, meaning if you do some process to them, you put them through some transformation physically, mathematically, whatever, they give you the same exact outcome. So we picked up just different nuances and considerations for logic. I put forth the idea that paradoxes don't exist at all. We'll discuss that more. We'll continue on our ultimate goal of differentiating sensorality with a C from sensorality with an S, and pairing sensorality with an S to speciality, the tendency to differentiate for sexual antagonism, more generally to differentiate. That is the operable word of speciality, differentiation. And so we have to pair some words there, pull apart some definitions, establish a new axiom, normalize that with a simple physical process that everybody's familiar with, and then reduce the linguistics, simply the letters, the words, representing the physics behind it. And so, starting with some logical things, we'll be jumping around. Again, I just write these things down. I do it all through the linguistics, through the words, and then I just write down the different topics and logical points that present themselves to me as I'm doing the derivation. And so we resolve the split path apparent paradox. We conjecture that there are no paradoxes. And so here's another one that everyone's always heard. If a tree falls in the woods and no one's around to hear it, does it really make a sound? And the answer is yes. Again, the core kind of underlying logic they're playing with is, what is the relevance of an observer, more particularly a sentient observer, a person or another animal that could hear the sound. But from our simple statement that everything is connected but nothing is touching, simply meaning electrons can't physically touch because of their charge, they repulse, it would take infinite energy, or at least approaching as much energy as we have access to in the universe to get two electrons to touch, so it's physically impossible. But everything is connected, so when a tree falls in the wood, it's still felt by the other tree, or still felt by that plant over there, or still felt by the dirt, or still felt by the air around it. And so it's a logical statement. It's not even that insightful. Really getting at just what's the role of an observer, or what's the role of sentience in general to observation. And does it make a sound? Yes, it just does. But another thing we can get to now is the spelling of arithmetic and algorithmic. Again, remember, we're going from rhythm to algorithm, and we've extensively detailed and provided examples for the iteration function, just showing how language fundamentally iterates with it is what it is as the general form of all sentences and of all structure. Equating two things, it becomes an identity. The word is becomes the word equality. But that's the general form. I've already derived the axiom speciality. We're deriving the axiom sensorality now. But you can see the fundamental iteration between the words arithmetic and algorithmic. Right? We have rhythm, and how do we spell that? And so now again, with this nuance to linguistics, every letter matters, every sound matters, every this, every that matters. And so rhythm is spelled R-H-Y-T-H-M, rhythm. But now we've iterated that to an I for logarithmic, algorithmic, arithmetic, like R-I-T-H-M-I-T-I-C. So we just have that rhythm going from R-H-Y to R-I-T-H. And so, again, we've covered, seeing the iteration of language should be apparent in basically every word you see at this point. But that one is fundamental to the words that we've presented, and arithmetic being as ancient as antiquity. Language maps numbers. Last episode we also talked about how language is more comprehensive than numericity, numerals, numbers. And so That's why you can't have. That's why Gödel's kind of logic was all, or that's why his exemplification of his logic was completely wrong. His logic was inconsistent and wrong in the beginning. But just another thing to show that language maps numbers is, go play video games. Go on to Xbox Live or PlayStation Go or whatever PlayStation's online service is, and all of the gamer tags where they're substituting numbers for letters, right? All of that is showing that language is more comprehensive than numbers, because if the shape of the number is even remotely close to the letter shape, then people can read it pretty much fine. And so again, that's just another exemplification of that, and people do that naturally. But continuing on, we also, again, just what is provable? We discussed how everything that can be proven will be proven in this manner, because fundamentally, when you really learn something at the intuitive, empirical level, individual level, is that aha moment, and then you have to transmit that to somebody else. So whether you're using a spoken language, a written language, some sort of symbolism to transmit meaning, anything you'd use to transmit meaning would embody these characteristics that we have described. So any way to transmit information would have to originate through vibration, and it would have to be articulated and built upon that. And so we have built out the logical structure in completeness and in comprehensivity. And so I wanted to make a differentiation between being complete and being comprehensive. We'll get to that in a second. But what is provable? Just in general, again, what does that mean? Is it something big? What is provable? Something that can be established as undeniably true, something certain with 100%. We know we have an infinite set of axioms we can prove. We have an infinitely larger set of truths that we can state that we know we can't prove. Then we have a bigger infinite set of things that we don't know if we can or can't prove that we can state, and so on and so forth. Again, keep generalizing of that. In that case, we're generalizing certainty. How much farther out can we say something that we reasonably believe is true, but we're getting further and farther from here's a proof, right? I have a notebook that is 100% certain because it's in my hand. All of the stupid philosophical, again, the people in philosophical history, to me, never come up in my lexicon whatsoever. There might be a word here or there, but to me, philosophy and psychology are not even remotely discernible subjects in terms of they've generated a unique section of ontology. But what is provable is just anything that is true. Existence is independent of being able to prove it. If there is a planet or a galaxy so far away that it's outside of the measurable universe, I have no way to know that for certain. But what was I saying? But is it provable? Can I prove that galaxy exists? No. Is that my ability to prove its existence? Is that in any way causal to any sort of determined thing to affect it? No. It exists outside of my knowing that exists. What is a proof? And again, a proof just establishes a fact. A novel proof establishes something that's never been done before. An axiomatic proof establishes fundamental linguistics. And again, linguistics is even emergent from vibration, right? I can do derivations. When you see my dichotomistic pairs, again, that is a generality of one word to a generality of another word. And typically before I write down a word, I've already jumped around 3, 4, 5 times between each word, because it gets to extreme redundancies, where I could write down every letter A and every letter E and every letter iteration of every consonant in every word. And you can even start to begin to think about it, right? If you just brute force calculated every word by just going through the dictionary, right? But it's not useful. So all of it is condensing of logic from the input to other people, the other intellectuals over history, to people today, all condensing the verbiage using, and again, it's all condensing to it is what it is, and then I differentiated that out into speciality. And I've been doing this for almost a decade on people's desks. So a proof is a complete establish of a fact and complete reduction of the linguistics used to describe it. And that's what we're doing. And again, once you see the actual result, again, when I did the speciality one, it's poignant. And on And on a personal level, again, I learn from the universe, and so it's a learning experience for me too. It's very it's very, very visceral. But it's kind of like losing your virginity. Not that I would know, because I am still a sexual virgin. But it's such a profound physical feeling, and it's just like. But also, it's like you probably remember the first time you got laid, but after the 57th time, if you're so fortunate, you probably don't remember that much being that much different than the 56th or 58th. Assuming you didn't do some crazy, raunchy, weird shit or something memorable. Point being is that it diminishes like any other sensation. It's like I've already proven a fundamental axiom in an environment where people were talking about dark energy and dark matter, like Darth Vader and Luke Skywalker's about to pop out or something. The Santa Claus is going to come down and deliver me presents. But what is a proof? Again, just posing that question to pose the question. Can't say much about it logically now, but I have demonstrated a proofing method that is completely reducible. You establish something that is true, it is complete. So we're back to that idea of completeness or incomplete. You can have complete local systems, or again, meaning like I can shut off my camera and that video is complete. I've completed the video. I've finished the video. I can eat a meal. I've finished. I've completed the meal. I can clean a house. I've completed something. And so you can't complete the universe, but you can complete subsystems within the universe. And so I've demonstrated a complete proof using linguistics, and then you reduce the letters and the words to the completely reduction of specialities into its pair of special and then ality. It's just showing that I put one suffix on a word that we use every single day. And so I just have to make that connection between sensuality and another word that we use every single day. And then it's like, well, what did I really present? Well, nothing really novel in the sense of, I just said, here, this bit of evidence, this word exists, and here is the information between those two words, and it's just a fucking vast valley mountain spaceship interdimensional super quasars amount of data. So that's what's going on there. But again, what is a proof? Posing that question to pose it. But it's a definition. It's a finite series of words solidified in meaning by relation to other words. Again, those sounds emerge from the physical world. Those sounds are then in turn used back to describe the physical world, so we can show consistency throughout. More on completeness. Again, local systems can complete. That's what we just discussed. We'll get to complete versus comprehensive in a second, because there's a good analogy for that. But I just said, like, I eat complete meals. I didn't eat all of the food in the world. So again, just subsystems can complete within the context of a bigger system. Something with three-dimensional components can be complete in something that's two-dimensional. Something in two-dimensional can be complete in something that's three-dimensional, as we see in all of these fundamental words, such as push and pull, right? So we have all momentum exchange as a push or pull. We've logically and physically demonstrated why you shouldn't break down pressure past that and say a force. We should just say force per unit area, because you have two three-dimensional objects. They're coming up and they're pushing together, approaching a two-dimensional shape, a plane, a pressure gradient between the two objects. And so we shouldn't break it down. We should not break down pressure into force. But all of those, whether it's a strong, weak, nuclear force, electricity, or magnetism, or what they call gravity, it's always a push or pull. So there's our fundamental stability of two embedded in a three-dimensional world. It's exactly what we see in experience. But then push, then pull is what I have. Because again, when matter, we go from vibration stabilizing into energy, again, still trying to figure out exactly what do I do with the word light, and then into mass, and that mass is vibrating, has a temperature, but it stabilizes charge. So when matter stabilized, charge stabilized. And so, boom, and then you have the repulsion of the electrons of stable atoms pushing away from each other, so you have a push, and then the electromagnetic force is a lot stronger than the gravitic force, so that's a lot stronger, so you're pushing away, and then you pull together because of gravity. So it's push, then pull. And again, we have a fundamental difference in then or than meaning sequentiality, a sequence, and than meaning comparison. So that's again rooting to fundamental stability of two. But I just said you can have completeness without comprehensivity. And so the analogy I wanted to use is kind of efficiency versus efficacy. Probably something you've come across in high school at some point, right? Efficiency, which is an operative word and basically our first physical axiom. And then efficacy, what is efficacy? Right, so efficiency is like if you burn an engine. If you have an engine and it burns 99% of the fuel, it is 99% efficient. Efficacy is like, well, if you're running an engine, if you need gasoline, it is not efficacious to run your engine just because it is 99% efficient. You need the gasoline not to burn it to run the engine to power. You don't need mechanical work done. And so basically the concept of efficiency is contained within efficacy. But just because something is efficient doesn't necessarily make it efficacious. And so that is the same thing to me as completeness is to efficiency what comprehensivity is to efficaciousness. Meaning there's more, you can completely, just using the store analogy that we used in the past 2 episodes, if there's a grocery store and you go down all 5 aisles and those are the only 5 aisles, you've gone through the entire space, you've mapped the entire space. So you've completely mapped the entire space. But let's say when you were going down the aisles, you were supposed to pick out the groceries while you were doing so. And so you add another layer of complexity. I don't like the word complex whatsoever, especially not in reference to numbers, but you add another step of nuance or resonance or intricacy is a word that I really like. Then you haven't been comprehensive. You map the whole space, you're complete, but you haven't been comprehensive with your completeness. And so I really like that analogy, and we're getting towards, again, we're using fundamental analogies with fundamental operative words contained within axioms. So now we're getting close. I've had a bunch of really good intuition breakthroughs in the past couple days. Lots of theorems, trying to get this thing done. There's no gradation of difficulty or importance. It's just information comes in, and at certain points in the proof, there's very poignant things that you can do with very cool implications. And so, again, it really always just comes down to the showing the iteration of the logic and establishing the axiom. But let me make sure I'm still rolling.